Hi, I'm Paul from Test Data Services, and in this video I'm going to show you how you can define a distribution of a subset of a population by age and gender so that you can actually tailor that for your test. So I'm just going to import the collection first, so you can do the same. The link to this collection I'm importing is down below in the description. I'm going to create a subscription key first, and then I'm going to define a distribution. So in this distribution, I'm saying 35% are male, everyone else is female. The mean age of this population is 25 years old, and the standard deviation is 2 years. Then I can visualize that with Postman's visualization tool. And when I click on visualize, we can see that this is that distribution. So that's quite useful. Now, the way it got this was it ran 25,000 discrete random samples for that curve using a high quality statistical map. And then it mapped it by what I'm calling decadays, so dates of birth in 10-day windows. And what that means is that now if I make a call to get skewed person, I will see in here, that's the date of birth here, then 1994, 1992, 94, 94, 96. But it's better than just the year. It actually goes down to the month. So this is very useful, for instance, if you wanted to simulate people in year 6 in a class, or high school versus a transition into college or university, or entering a retirement village, or a threshold for moving from one stage of life to another, like nearing retirement or whatever. So there's quite a lot of occasions where the interactions you have with an IT system are dependent on age. You might have extra questions if you're under or over a certain age, and it's really good if you've got that mix right and you don't want to have to do arbitrary messing around with data to get there. So let's just go back. Now I've showed it to you, and let's change this mean age down, or let's make it up to say 90, and let's give it a standard deviation of 0.2 years, so quite tight. And now let's look at this profile. So we'll see 90 in the middle. There's the 90. And now we've got a much tighter profile. So given that most of the people are between 89.5 and 91.5, I'm expecting that if we now fetch a whole lot of identities, that they'll all be pretty much the same year. So we've got 1930, 30, 30, 30. Now look at the names: Mary, Lorraine, Lewis, Thomas, Richard. Now these are all names that were popular at that time, because the data that I've got here has ages, like this one, Dorothy, that are set according to birth year, according to what the prevailing popular names were. Joan, Dorothy, Bernice. Some of them are still popular. Carol, there's Carol, Alice, Gerald, Johnny, Nadine. So you can see that there's quite a lot of value. If you were doing something for, say, a retirement setting and enrolling a whole lot of people in and testing that, or maybe doing some integration testing with other interfaces, it's nice if the names in your data set that that come up when you bring up a screen look like they are people who should be in a retirement village, as opposed to, say, modern names. Just one more time, let's go back and let's change this to, say, 0.99 for male. Oh, I'll go the other way. 0.01. Let's make the age, say, 9 years old, with a standard deviation. Yeah, if I can type, standard deviation of 0.5. Send. And that's all it takes to do that. And then we can just get the workload profile to see what it looks like. And there we go. We've got, you can see these dots are almost on top of each other. The actual population is almost the same as the number of females, and our males are down here with almost nothing. If we were to change that back to 0.5, send, and then view. The amplitude of the graph will be the same, but now we've got a even mix of genders in here. And if we're talking 9-year-olds, now when we do it, we've got year of 2011, and we've got names like Jalen, Brady, Sophie, Cohen, Angelique, Colin, Oliver, Liam, Sophia, Gabriella, Gavin, don't know how to pronounce that one, Ava. So you can see that the data is nicely set. So I think this is a useful tool. Only really one call to specify the distribution and another call to actually retrieve identities from and according to that distribution. And if you wanted to have 5 different distributions, that's easy. You just create 5 different subscriptions and create a different distribution for each of those subscriptions. Hope you find this useful. Have a great day.